So you'll notice that there's going to be some overlap between my talk and Brian's, and probably between everybody else's talk and Brian's, because he basically covered what is going to inform all of the rest of our talks. So I'm going to be talking about how fire seasonality is impacting plant diversity and woody vegetation control. All right, so we're talking about longleaf communities down in the coastal plain today. So these communities are typified by a very open canopy of longleaf pines dominating that canopy with a very herbaceous understory. And what that means, or ground cover, I should say. And what that means is basically all of the stuff from your hip down to the ground is going to be things like native warm season grasses, wildflowers, legumes, all of those non-woody herbaceous plants. And we a lot of times like to refer to this as an old growth grassland with trees embedded within it. And these communities range everywhere from super wet when we're talking about stuff like flatwoods and savannas to super dry when we're talking about things like sandhills, and especially like xeric riverine sandhills. And so you can see that's the region that we're covering here. And then it's probably pretty hard to see, but you can go all the way from very wet hydric soils all the way to very super xeric dry sandy soils. And what are the species of plants that we're finding in the ground cover of these communities? Typically, they're what we like to refer to as heliophytes, sun-loving plants. Now, they don't all have sunglasses, but they do all really enjoy having sun in order to grow and have young. And like Brian was talking about, these communities have exceptionally high diversity and especially endemism, which means that plants will only grow in these communities. They don't exist beyond there. We have some things like little blue stem that grows in those communities, but also grows across like 47 states. We have other things like wiregrass that's pretty much tied to those longleaf pine communities. And on the small scale, like the meter squared scale, when you're doing plant surveys, some of these more mesic longleaf communities rival the Amazon rainforest in terms of plant diversity. And so what was maintaining that super diverse ground cover underneath those trees? Why didn't it turn into hardwood closed canopy forest like it does if we just stop doing things today? The answer is fire, and pretty often recurring fire. So we're looking at here a return interval of 1 to 2 years, sometimes as often as like every 18 months. And like Brian was saying, these fires could burn thousands and tens of thousands of acres. The compartment sizes were much larger, which meant that they were burning in a area that had various fuels of different densities, moisture levels. So we had very patchy mosaic burns. So that diversity of how fire moved across the landscape reinforced the diversity of vegetation. So those fires were mostly started by lightning strikes. There was some aboriginal burning, but that was more common once you get out of the coastal plain. And that's telling you that probably most of these fires were during that growing season, because that's where we're getting the things that were initiating fires. So how does the fire impact the plants? Well, one thing is it can kill plants outright. So we have plants that either survive or don't survive. And they either survive like a longleaf with the adult stem above ground, or they survive like hardwoods where you may kill the top stem, but they resprout from the root crown. You also have stuff that comes up from seed brand new after the fire. You have stuff that's stimulated to flower and produce seed by the burning. And you have stuff that's going to seed in from outside of the burn unit following that fire. So there are different ways that all of these plants can respond to that fire, and that diversity of the responses is what gives us that big diversity of vegetation species. And so we kind of want to focus on some of those groups because they're the dominant groups that we're going to be focusing our land management on when we're talking about managing for wildlife and natural communities. And the first one is going to be native warm season grasses. And those are important because not only are they diverse within this community types, but they're providing fuel for future burns. So in a lot of these communities, if they're open enough, you don't have a continuous source of pine needles as a burn for the entire unit. So you would have additional fuels, fine fuels in the form of grasses. They're also important as nesting substrate and food for some of our wildlife species. And historically, it was dominated in a lot of areas by wiregrass, and then in the wiregrass gap in South Carolina and the further west of wiregrass range along the Gulf Coast, dominated by various blue stems, especially little blue stem. But right now, if you go to a lot of our pine stands that have been planted into old field situations where they had been row cropped for some time, those stands tend to be dominated by more old field specific blue stems like broom sedge and split beard. So how does the seasonality of fire affect those? Well, we see that stuff like Brian alluded to earlier, wiregrass is only going to really flower very well and set high quality seed when burned during the growing season. You'll see some plants that will set seed after a dormant season burn, but oftentimes you'll find that that seed is not viable. It's there, but it's not going to grow. It's not going to germinate. So we know that by burning during the growing season, we can reinforce and spread wiregrass. We also see that early growing season and lightning season burns can stimulate some of our other more important species, such as little blue stem and pineland dropseed. But when we're looking at the typical native warm season grasses found in a lot of these old field situations, stuff like split-beard blue stem, broom sedge blue stem, purple threon, we don't see any coherent trend with the seasonality of fire having a big impact as far as flowering and seed production with those. The idea is more that burning itself is important rather than burning at one time or another. And so another group of species that we really tend to focus on when we're doing ground cover management is going to be the legumes and wildflowers. Now, legumes are the things that you're thinking typically are going to provide high quality forage for wildlife like white-tailed deer, gopher tortoises, that sort of stuff, also producing seed. The wildflowers, a lot of those are going to be stuff like composites, your aster family, sunflowers, black-eyed Susans, that sort of thing. And those are going to provide seed for wildlife to eat, as well as all of the floral resources that stuff like pollinators need. And we find again that the response to fire seasonality with these is very variable, and it's dependent on the life history of the species. So there's not really a way that you can say, hey, you burn at this time and legumes are all going to respond this way, or you burn at this time and all of your aster species are going to respond this way. It just doesn't work that smoothly. But we do tend to find that with both of these groups, there are some kind of general trends, and that is that it tends to delay the flowering times for those things that are flowering earlier in the season. So if I burn something that's done half of its growth and it's supposed to be flowering next week, it's probably going to end up flowering a month from now instead of right when it was supposed to, because it has to put on more growth before it can flower. We tend to see an increase in the abundance of individuals that are going to flower in any one given year. So there's going to be more of that species out there that will flower that year as opposed to a typical year following a growing season burn. And then the number of flowering stems per individual. So not only do I have more individuals that are flowering, but each individual might be putting up 10 flowering stalks instead of 2. So that means there's a lot more flowers on the landscape following a growing season burn a lot of times. And then it tends to increase the synchronization of flowering for a lot of these species. So you may have a species that would flower over the course of maybe a whole month, where that flowering time gets compressed into, say, only 1 or 2 weeks, where everybody's flowering at the same time. Repeated growing season fires can also lead towards more of a dominance of those late growing season, late summer, and fall flowering species, because you're inhibiting some of those earlier flowering species from getting to produce seed in that year. And there is some indication that it may reduce seed predation on some of our legume species due to weevils. You see a lot of goat's rue and indigo pods will be depredated by weevils, and growing season fire tends to have some impact on those weevil populations. So what are some of the benefits of growing season versus dormant season burns for these communities? Well, that increased synchronization of flowering leads to an increased synchronization of seeding as well. So if you have all of the flowers are flowering at once, they're much more available for pollinators to pollinate, but also to have increased genetic exchange across that stand, so that there's better gene flow, as well as the fact that when they do then turn around and drop seed, we have this increased seed rain that kind of does the same thing as an oak masting, where there's so much seed that the predators can't eat it all. So we're going to hopefully have better reproduction in that season, as well as it's reducing duff and preparing a seed bed, similar to what you may do if you have a good longleaf cone crop coming on, where you're going to burn and then have a nice mineral seed bank for all that seed to fall on and have a better chance of germination. And if you're somebody who's wanting to do a lot of natural community restoration, it makes seed collecting easier. If you have all of the stuff is all flowering and seeding at the same time, it's a heck of a lot easier to go out there and strip seed off of, or run a flail vac or a combine through and get a bunch of higher quality seed. And so one other important thing before we get to the woody plant control that Brian kind of touched on earlier is burning for some of these seasonal wetlands. So this is an example of a Carolina Bay. These seasonal wetlands a lot of times had either no canopy or a very open canopy, and had a ground cover typified by grasses, sedges, rushes, and some other herbaceous vegetation. That's the kind of stuff that a lot of our amphibian and reptile species are using. Fire exclusion or burning during the dormant season tends to lead to much brushier or treed ponds that have reduced quality for those wildlife species. So if you see here, if I'm burning in February or March, when we're typically pretty wet, less of that fuel is receptive to burning. It's surrounded by water. We get into April, we start drying down, and I can now burn more of the fuels around there. We get to June, that pond's dried down to half the size, and more of the fuels are available for me to burn. So not only can I burn more of the pond, but I do know that growing season burns tend to be better at controlling woody vegetation. So that's kind of a twofer right there. You're burning more and you're getting a better burn on it. So keep that in mind when you're dealing with embedded wetlands, whether they be, an isolated depressional pond like this, or more linear or other sorts of wetlands. And so those are the ways that herbaceous vegetation is responding to fire. And we know that the way that we keep that herbaceous vegetation there is by controlling the woody plants that would shade them out. So we've all seen pine stands like this. This was thinned, then it wasn't burned often enough or burned at the right time. And we end up with a mass of sweet gum underneath that's shading out everything that we do want to grow on the bottom. So that decreased sun is decreased plant diversity. And a lot of times that's going to be mesic species like sweet gum, water oak, live oak. And those are things that we tend to think of as fire decreasers. The fuels that they have when they drop leaves are less likely to burn than longleaf needles, than turkey oak needles or leaves, excuse me. So those are species we want to keep out. And those woody species that can be an issue is going to depend on the natural community that you're in. So in sandhills, a lot of times we're dealing with an overabundance of scrub oaks, persimmons, and sassafras. Those are all species that are on site that are supposed to be there, but we just have too much of a lot of times. In flatwoods, you're dealing a lot of times with evergreen shrubs like gallberry and fetterbush and tie, or saw palmetto. Again, those are on-site species. They're supposed to be there, but they can be too much. And then in our sub-xeric and mesic woodlands, a lot of times we're dealing with stuff that's off-site, like sweet gum, water oak, laurel oak, and even red maple sometimes. And those things can be a pain in those productive sites. So how is fire dealing with these woody species that we don't want? Well, first, it's going to thermally girdle and top kill those stems. And then also any of the stems that have resprouted from the last burn, we're gonna kill those. And when they resprout, we're robbing energy from them by forcing them to resprout. We're gonna kill any young sprouts or seedlings, I should say there. So any seedlings that have come up from the last burn, we're gonna kill them before they have the chance to get any energy reserves down in their root mass. Now we know repeated fire is going to keep that woody vegetation from outgrowing fire. If I burn every 2 years instead of every 3 years, I can keep that woody vegetation this tall instead of 10, 15 foot. It's a lot easier to kill when it's this tall than when I can't reach the top. And we do know that the effectiveness of fire on killing those things is going to depend on the intensity of that fire and the phenology of that plant, whether or not that plant has leafed out. Because when it's leafed out, I'm going to steal more energy from it than when it's not. So what's the difference between dormant and growing season fires when it comes to woody vegetation control? Dormant season fires affect plants when they are inactive. It's dormant, so all its energy is stored down below. I top kill it, yeah, but it's got the entire growing season to respond. If I do that in the middle of the growing season, not only do I rob that plant of the energy reserves for that growing season, but then it has to grow and get as much as it can in only half of a growing season. We're also leading to increased water stress for those resprouts, because if I burn in March, those resprouts are coming up when they still have water, where it's not super hot, not super droughty. If I burn in June or July, those resprouts are regrowing when it's starting to get hot and it's starting to get dry. So they don't have the same good environment to come back up into. In both dormant and growing season, fire intensity is going to vary with the weather, the fuels, the fuel loading. Keeping in mind that growing season fire, it's probably going to be higher in temperature just because it's 95 degrees out there. So we're going to get some increased intensity just from that temperature alone. We do tend to find that dormant season burns lead to greater resprouting and higher stem densities. So I kill one stem, it comes back as 3 or 4. Growing season burns tend to have less of that resprouting. Now they're going to resprout, but they're not going to come back with 10 stems for every one. They're going to come back for 1 or 2. So we generally don't see a super high increase in stem density, but we are robbing more energy reserves and we're getting increased water stress as well. So takeaways: fire season can have an impact on woody response. Fuel types and loading are going to be important for that woody control. And diversity of burn season is going to lead to a greater diversity of vegetation. You can see here, this is the Stoddard plots at tall timbers, and they've been burned this way for it's like 60 years now at this point. This is just dormant season burning, but with different return intervals. This has not been burned. This is a 3, a 2, and a 1 year cycle. And you can see the difference in woody vegetation component in these just based off how often they're burned, all with the same season. So fire frequency is the most important thing. If you burn, you're going to want to burn as often as you need to keep the amount of woody vegetation to your preferred level. And there's no wrong fire season. Don't listen to anybody who says you have to burn at this time or you have to burn at this time. By expanding that fire season and burning, from February all the way to July, you're expanding the time that you have available to burn, and you're expanding the amount of responses that you get from vegetation. So while these areas may have burned during the growing season historically, keep in mind that fire is a land management tool. We're using them in an attempt to recreate a natural process, but let's face it, fire, no matter how we apply it, does not work the same way it did pre-Columbian times, like Brian was talking about. I can't pull a permit on a day that it would have historically burned because they don't want that fire to get away. I can't burn 15,000 acres in one burn unless I'm, like the Army or something. Because I don't have 15,000 acres to burn. And even if I did, there's going to be a break somewhere on it. So burn the way that is going to get you the response you want from the plant communities that you're dealing with. Don't be afraid to burn in February and March, but also keep your mind open and start thinking about expanding that window and seeing some additional different responses from the plant communities that you've been managing if you've been typically doing only dormant season fire. So with that, I'll take any questions.
Not 35.
So they're going to issue permits based off more the conditions the day that you're wanting to burn, and you can talk to some of the GFC folks about that as well. But the idea is more like what I'm saying is traditionally that stuff would have burned on a hot, dry, windy day where you get a lightning strike and then that takes off. That's a day where fire conditions are very dangerous. So I'm not going to be able to pull a permit on a day like that. So I can tell you that no matter when I burn, my fire is not going to be the exact same as a fire that starts naturally on a red flag day. That's just the way it's going to be. But you can burn, 365 days a year, assuming that you have the right weather conditions to burn.
All of them. We burn, we look afraid of getting into it.
Mm-hmm.
And this thing, legislature just help us with the liability that's involved with burning. And also, we also need to burn a lot later in the daytime, night. If we could get so we could do that, like we used to years and years ago, you would burn the fire for a lot of time. That at 5 o'clock in the afternoon, allowed to burn during the night.
Yeah, and so
eliminate the wind factor.
we do have some pamphlets that covers the liability, and you can talk with the GFC folks more. But assuming that you're burning with a permit and with a plan under the conditions that that plan says, there is some protection on liability. As far as burning at night, nobody's saying you can't burn at night, but those conditions are a lot more specific to be able to make sure that we're not setting smoke down on roads and having increased liability. So again, that would be something that Shan and the GFC folks would be more able to tell you about the specifics on that one. I'm not the guy to ask that.
And, you know, my complaint is, this is report before, the love. They're risk adverse on giving out permits, so the only time you can grow without a permit is you got a hand stack pile. Doesn't say you have to have a fire permit where you can hand stack pile. So I'm just curious as to why the department, why the hesitancy to give burn permits on the day that it will burn.
So generally speaking, they're taking all of the weather information from different sources and getting information to best come up with a plan that will reduce wildfire risk. So obviously, we're trying to manage these stated ecosystems. We're trying to get the best burn days, but we also have to account for issues that we can run to on neighbor properties. So your fire gets out and
That's why I asked how often does that happen, or it could happen.
there's a decent frequency in wildfires, but I don't have that data on me to get to you, but I can get you that data if you need.
Well, I'm just like, just curious for discussion, because seems like the humidity goes below 20% and the winds are over 15 or 20 miles an hour. A lot of times what it takes to get through the vegetation, trying to burn, to get the temperatures we're interested in, to kill the vegetation. It's a no burn situation. The best burns I've got is I called at 8 o'clock, got a burn permit. They cut down permits later in the day and I was already out burned. I got good results with stage burn and accomplished what I was trying to do. And it just seems like it is kind of frustrating to have a good burn day. We told no, we're not issuing permits.
Another thing about these guys, they're in charge of wildfire control. So it might be a good burn day, but scary in the summer, and they're out on wildfire. Like, oh, those dozers are putting out wildfires everywhere. So they might limit permits because if your fire gets out, then they can't send anybody to help you. So they got a lot of these things.
So their website says Georgia averages over 2,300 wildfires annually. Their average size is about 7 acres.
That's wild.
Out of state.
How much
Right, Bertha got out.
We do have those numbers, but we have.
Respond to is somebody's got their backyard, they've got pile of leaves, that gets out. That's not like a fire. That's a dump